Huh?
That would be a thing.
Yeah. Okay. Let's think here. Okay, so this one, I hadn't had a chance to get it all written down, so I just have a copy of the answer key. It just doesn't have my handwriting all over it. Okay. Yes, he does. He made them for me. All right. So simulations. Does anybody know what a simulation is? I mean, that's a good guess. Like a life simulation. Fake. Okay. What about in like big malls or anything? Have y'all ever seen those where it's like you're skydiving? You go in and it's the wind that pushes you up, but you're not really having to that is a skydiving simulation. What about the hurricane booths? And it does all the wind coming out of it because it's simulating what it would be like to be in the middle of a hurricane. Okay, simulating is trying to recreate an event. Okay? And then a prediction, what does a prediction mean? Okay, so a prediction is something that you think will happen. Do you agree? Does he need a copy of the one I have? Coach, does he need one of these?
Yes, he does.
So Cooper's brother's like getting his pilot's license, and he has to use television. He has to do a lot of the flights.
Oh, yes, that's a good one.
And it's like he's flying an airplane. It's just like
virtual reality, those VR headset. Is that a simulation of something? Yes. Yes. Okay. So in order to obtain the probability of various events, a simulation is often conducted. It allows us to represent the likelihood of a real-life event occurring by using an experiment with similar. So you were right, Xavier. I said you were right in using that word. Similar probabilities. Okay, it says this method is used by researchers when it's difficult to collect experimental data or when the theoretical probability is unknown. So when they can't go and physically collect data from a situation, they're going to simulate that event. Okay? So examples of a simulation that like we could easily do. Like if I wanted to know how many times I flipped a coin and how many times it would land on heads. Is that an easy simulation to do? Yeah. So tossing a coin. All right, rolling a dice. I'm just going to write some examples because we're going to use them in a minute. We're not calling the dice a number cube. Deck of cards. And using... Ooh, I did make a seating chart for y'all. The reason I said that is because it says using a random number generator. I use a random name generator. We might wait. Our focus today is getting through our notes. Okay. On a multiple choice question, there is a 25% chance of getting the correct answer. So this says brainstorm a simulation that could represent the same probability as the following situations. So we're going to kind of use these as our examples. Okay, so on a multiple choice question, there is a 25% chance of getting the answer correct. What could you do? What's an example that we could do to kind of represent that situation? Any ideas? Or do y'all want me to give you one so you kind of know what to do on the next three? Okay, so I would need something that was 4 equal sections, right? So if I got a spinner, all right, let's say that I had a spinner in a game. You don't have to draw this part. If you want to, you can. And I had a spinner and it had 4 equal sections. Do you agree that you have a 25% chance to get each one of those? Yeah, so we'll say spinning a 1 on a spinner with 4 equal sections. Spinning a 1 on a spinner with 4 equal sections. Okay. The weather report shows that there is a 50% chance of rain. Look at one of these. Which one would represent a 50% chance of doing something? Tossing a coin. Okay. If it was a 50% chance of rain, what is one side of a coin? Okay, so tossing a coin and landing on heads. Okay, an average basketball player makes 66.6% of his free throws. Okay, that is 2 out of 3. Good. That's 2/3. All right. What's an example for that one? I don't like their example for that one. Rolling a 1, 2, 3, or 4 on a number cube. But how that would... Oh, okay, I see what it's... No. Oh, but that is 4 out of 6, so that's 2/3. Can y'all think of a better example? 2 out of 3 chances. Couldn't you use... Could we use this example again? Except instead of having 4 equal sections, we have what? 3. Because if I had a spinner and I had 3 equal sections and they were labeled 1, 2, and 3, okay, so we spun a 1 or a 2, okay, 2 out of 3 times. Y'all agree?
Yep.
There's an equally likely chance that a baby is a boy or a girl.
Coin 50.
That is 50-50, right?
Yeah.
Okay. I would use that. Tossing a coin and landing on, since we used heads, we'll use tails.
My friend just had twins. And they just knew it was girl and boy, girl and boy, girl and boy. That's what we were all looking for. And they didn't find out the genders.
Oh,
And she had them yesterday, and it was 2 boys.
oh my gosh.
And there's
What would be like the percentage of like
Mom
like
won't say
if you had like
how to be
triplets
right.
or twins? Like, do you know the percentage of that? Because it could both be.
So that's how, so to find out, that's a good question, Hattie. So to find that out, the other day we made a list, right? So could you make a list to find out what is your probability? Yeah, that would work. That's a really good example of how to use that. Because I could put boy, boy, girl, girl, boy, girl. So really, it's a 1/3, pretty much, 33% chance of getting one of those. All right, so Mr. and Mrs. Pinkerton have 4 boys. Every time people notice, they comment about the odds of this happening. The Pinkertons decide to set up a simulation with 10 trials to determine the probability. What simulation could be used to represent the likelihood of having a boy or a girl? Well, we've already said that, right? Was tossing a coin a good simulation of that? I have a 50-50 shot, right? So we can put tossing a coin.
We can just put it in class.
I don't know. Which outcome represents having a boy? Which outcome represents having a girl? So if we use this as our example, which one would represent a boy? We can make it up. Doesn't matter. There's no... Okay, so we would say tails represents boy. Heads is a girl. Hey, they said it, not me. I didn't make it. I said, you tell me. They said tails.
Because they're meatheads.
I mean, you said it.
I got
How?
three, it's all right.
Yeah, you got 3 of them.
boys.
All right, how should the simulation be designed in order to account for 4 different children? What would they have to do with their coin for a simulation? You don't cut a coin? What did we say we're doing with the coin? We're tossing it. So how many times would they have to toss that coin? So they would have to toss the coin 4 times because they were trying to feel they're doing a simulation with the coin to represent 4 times they had a kid.
Would there ever be a 3-sided coin?
No.
Hey, that'd be
How do you know I'm pretty?
How do you have a flat cone with 3 sides?
It could be
A
like
flat cone with 3 sides.
You know,
Hey,
I just need to start keeping a journal
I did that in pre-K.
of the things that I hear. I did my first year in Glenn. Yeah. Like the questions that I hear, they're quite comical. All right. That would represent, okay, so the 4 times I tossed it, what is that representing? What are we trying to simulate?
how many
Have 4 boys.
Well, they have 4 kids, right? So they wanted to simulate that event of the odds of that happening. So that would represent all 4 children. In one family.
Miss Houston has 5 girls. I don't even know.
My uncle has 4 girls.
My cousin has 4 girls.
And then out of us 4, there's 3 girls and 1 boy. My mom, 2 girls and 6 boys. Yeah.
My
Okay.
dad, my grandma has.
Yeah,
My dad's from Middle Town.
My grandma
has
has
3
9
boys.
siblings.
Oh, nice.
Okay, look at this. Guys, we need to refocus real quick. The Pinkertons decide to set up a simulation with 10 trials. How many times would I have to toss the coin 4 times?
40.
Then repeat 10 times. And like Trey said, for a total of how many tosses?
40.
Are they probably trying to see like the odds of it? The odds of what is the odds of having 4 boys every time?
My grandma has 9 siblings.
Yeah, that's just crazy. Oh, sorry, some of y'all aren't done.
couldn't it depend on how
There's only 2 girls and the rest are boys.
So when Hattie, you are full of good questions today. When you are conducting a simulation, you have to do it the exact same time every time. So if you started changing up your styles of flips, then it wouldn't really be valid. You have to keep it the same every single time.
Yeah.
I got a good example of that. Can I share?
Yes.
So my boys are big cornhole players, and they were keeping up with the national cornhole tournament, and you win like $15,000. So that it's fair, it's the same distance, it's the same, and it's just basically your luck, I think, and your skill. Anyway, so these men that won $15,000, it came back that they were using lighter bags, so they could throw them farther. Anyway, so yeah.
Cheaters.
So like that increased their odds of winning because they were cheating.
Did they get the 15,000?
They had they free.
Okay.
Are you frustrated?
No, I was trying to think of the easiest way to get this next number. Okay, the probability of rolling a 6 on a number cube is 1/6. So when I make predictions, like we said earlier, we're trying to predict the future occurrences by setting up and solving a proportion. We know proportions, right? I feel like we've done proportions more than any other type of solving so far this year. All right, so it says the probability of rolling a 6 on a number cube is 1 out of 6, right? 6 sides, there's 1/6. If it's rolled 50 times, then approximately how many times would a 6 be rolled? So where would 50 go on this side? Top or bottom? Bottom. That's my total number of times I rolled it. Okay, so could I solve that? Yeah, how would I solve that? Cross, multiply, and divide. Beautiful. So 50 divided by 6. Well, what times 6 get me closest to 50?
8.
Okay, I have 48. I have 2 left over. Okay, so here's what I can do, especially with probability, because how have we listed probability so far? In fractions? So to make it easier so you don't have to do decimals, I could do 8 and 2/6, which 2/6 is the same as what? 1/3. So 8 1/3.